Every car has a beating heart, a complex, powerful, and precise machine that turns tiny explosions into pure motion. But you ever stop and think, how is that thing actually made? How do we go from raw molten metal to a perfectly tuned mechanical symphony? Well, let's dive in and follow the journey from the very beginning.
Right, so we've all seen this kind of picture. Yeah, robots, sparks flying everywhere on some futuristic assembly line, putting together the body of a car. But here's the thing. The engine, the most complex part of the whole vehicle, that's a whole different story. It has its own origin, happening in a completely different kind of factory. So first things first, we've got to understand where the engine even fits into this whole puzzle. And trust me, it's not just another part they bolt on at the end. Its creation is like a whole parallel universe of manufacturing. Okay, so take a look at this. You've basically got two separate worlds running side by side. On that top line, the car's body is getting built, pressed, welded, painted. But at the exact same time, in a totally different powertrain plant, they're building the engine, the gearbox, the axles. They don't even meet until the very, very end, at a station they call, and I love this, the wedding, where they're finally joined together. All right, let's rewind and go right to the beginning of that powertrain line. This is where the magic, or I guess you could call it alchemy, really happens. We're talking about turning basic, raw elements into the core components of the engine, using incredible heat and pressure. It all kicks off with a process called casting. This is basically how they make the main frame, the skeleton of the engine, what's called the crankcase. Think of it as the house for all the moving parts, made by pouring liquid metal into a mold. For an engine block, the go-to method is sand casting. First, they pack sand super tight to make a precise mold. Then, and this is clever, they stick these other intricate sand cores inside to create all the internal tunnels for oil and water. Then, they pour in the molten metal. Once it's all cooled down, they just smash the sand mold away, and boom, you've got your rough engine block. And this right here just perfectly shows you that transformation. I mean, look at that. On the left, you've got this super detailed but totally disposable sand core. And on the right, the solid, permanent, powerful engine block it helps create. It's just amazing. A perfect negative image born in fire. Now, for some parts, like the crankshaft, which takes a ton of force, casting just won't cut it. It's not strong enough. For that, you need something called die forging. This isn't about liquid metal. This is brute force. You heat up a solid chunk of steel till it's glowing red hot, and then you literally smash it into shape. What this does is it lines up the very structure of the metal, making it unbelievably durable. And this sequence shows you exactly how that goes down. It starts out as just a boring old steel bar, but then it gets rolled and pressed again and again in different stages, slowly getting squeezed into the complex shape of a crankshaft. Here you can see the two key players. On the left, that's the hardened steel die, a perfect mold of the part. And on the right, the glowing hot crankshaft that comes out of it. And get this, this all happens under pressures of up to 12,000 tons. To put that in perspective, that's like stacking more than 8,000 cars on that one little piece of steel. It's just immense. Okay, so we've used fire and sheer force to get our rough shapes. But an engine has to be precise, right? So now, all that brute force has to give way to microscopic accuracy. We're talking about machining these parts down to a precision that's literally thinner than one of your hairs. And that's done with two main processes, milling and drilling. Pretty straightforward, right? Drilling, well, it drills round holes for bolts, for oil to flow through, you name it. Milling is more like carving. It uses a spinning cutter to shave off metal, creating perfectly flat surfaces or really complex shapes. You absolutely need both to get the job done. And here's what you get at the end of all that. This crankcase started life as a rough, sandy piece of metal. But now, after all that milling and drilling, its surfaces are perfectly smooth, the cylinders are flawless, and it's got hundreds of super precise holes and channels that are essential for it to work. It's less like a factory and more like a studio for robotic sculptors. All right, so now we have all these perfectly machined parts. Time to put them together. And there's one part of the assembly process where manufacturers use this incredibly clever and frankly kind of weird trick. So let me pose a little puzzle for you. Imagine you have a solid steel ring. You need to split it in two so you can wrap it around another part, but then you have to bolt it back together so it's a perfect, seamless fit every single time. How would you do it?
The answer? You don't cut it. Step 1. You take a laser and etch a super fine line on the inside of the part. It's basically scoring it, creating a tiny, pre-planned weak spot.
And then comes the part that sounds completely wrong. A machine gives it a sharp, quick whack and literally cracks it in half. Yeah, you heard me. It's not a clean cut, it's a fracture. And that means the two broken surfaces are jagged and totally unique, kind of like a 3D jigsaw puzzle.
And that is where the genius comes in. Because that break is one of a kind, those two halves can only fit back together in one perfect way. Those jagged edges lock into each other flawlessly, making the connection super strong and precise. It's incredible. They literally have to break it to make it perfect.
So, with that clever trick sorted, all the main players finally come together. We call them the Big Five. You've got the crankcase, the rotating crankshaft, the connecting rods, the cylinder head on top, and the camshafts. Once you bolt on all the other bits and pieces, like the turbocharger, you've got yourself a complete engine ready to go. So that was the story of just one engine. But to really get the full picture, we've got to zoom out and look at the sheer scale of the factories that crank these things out by the thousands. I mean, this isn't just a big garage. This is the Volkswagen engine plant in Chemnitz, Germany. We're talking about a whole manufacturing city that does nothing but build engines. For most car companies, these plants are their crown jewels, supplying car factories all over the globe. And the numbers here are just hard to wrap your head around. That single plant we're looking at, it can churn out up to 4,000 engines. Not a month, not a week, 4,000 engines every single day. The amount of planning and precision to make that happen is just unbelievable. And all of this leaves us with a really big and fascinating question for the future. You know, we've spent more than 100 years perfecting this incredible art, this dance of fire and metal and precision. But as we all know, the car world is shifting, moving towards electric motors, which are frankly a lot simpler. So you have to wonder, what happens to these massive, incredible cathedrals of combustion and all the amazing skill that goes on inside them?